Well, let's talk a minute about that first example we had about that particle moving along the number line and turning around and moving back. And we said that at 0 seconds, it was at 0 at 1 second, it was at 2 seconds it's at 1, and so forth, okay? Let's assume that this number line represents feet. Like this is 1 foot, that's 2 feet, that's at -1 this way, okay? So we can say -1 foot from 0, -2 feet from 0, which technically is 1 foot to the left and so forth, but y'all get it. All right, anyway, we graph this out, position versus time function here, okay? Now, how would you describe the total distance traveled by the particle? And how would you describe the displacement? Well, for the displacement, what you would say is, okay, where did it start at? And then where did it end? How far apart are those basically, okay? So let's see, it started at 0, the number line. It ended at what? -3 when this particle traveled, because it went like that, and it went like that, right? So displacement is going to be 3 feet. This particle is displaced 3 feet from where it started. So it's basically the last position minus the first position, okay? Now let's look at distance traveled. Distance traveled. Let's think about this now, okay? The distance traveled. Traveled here, traveled back here, then it traveled there, right? Or how far did it travel? It traveled 2 feet from here to here, right? So it traveled 2 feet plus from here to here to 1 to 2. Then it traveled from here to here, right? From 2 to -3. So it traveled 1, 2, 3, 4, 5 more feet, right? Or we could say 7 feet is the total distance traveled. Well, how do we find that whenever we're given this graph here? Here's what we're going to do. What did we do here? We looked at how far it traveled going right, then how far it traveled going left, right? Then we said if the particles moving to the right are positive, my position curve is going up. If my particles moving to the left, my position curve is going down, right? So I need to add up this distance that is going right, plus this distance is going left, okay? So what is this distance from here to here? Now keep in mind, these order pairs, how do they look? Yeah, they look 0, 0, 1, 2, but they're going to look like this. They're going to look like the number of seconds, comma, and then the number of feet. So right here, at 0 seconds, I'm at 0 feet. And right here, at 1 second, I'm at 2 feet, right? So how far did I travel right here? I traveled 2 feet, right? And normally what we do is we say this. We say 2 minus 0. Or in fact, another way we write this is we say, okay, this is the ordered pair t, comma, s of t. So what we say is the absolute value, the total distance traveled, be the absolute value of s at 1 minus s at 0. That'll give me that total distance traveled right here. And think about it. What is s of 1? S at an input of 1 gives me 2 minus s at 0. Remember, this is t, s of t. So s at 0 gives me 0. So 2 minus 0. All right, then we need to add this distance traveled from here to here. In other words, my particle was going to the left. So I need to add another distance. Now for distance, we're going to put it in absolute values. Therefore, if we screw up on a negative sign, it's not going to matter because we're putting it in absolute value anyway. Okay? Now what I do is I say, this output here, so S evaluated at 4, minus this output up here, S evaluated at 1. Let me actually put it up here. Plus absolute value of S evaluated at 4 minus S evaluated at 1. So my position function evaluated at 4 minus my position function evaluated at 1. What was my output of my position function at 4 seconds? -3 minus the output evaluated at 1 second. The output evaluated at 1 second is what? 2. Well, what does this give me? 2 minus 0 is 2. Absolute value of 2 is 2. Plus -3 minus 2 is -5. What's the absolute value of -5? 5. So what does that give me? 7 feet. Same as we got before, right? So how do we do it again? The part where you're increasing, you do that distance. So it'd be the output minus output in absolute values, plus the part where you're decreasing, which will be output minus output in absolute values. Okay, keep that in mind whenever we work the next example. Alright, so if you look in your notes, you have an example, and it asks you for a bunch of different things now. Okay, so we start out with an example that has S of t. S of t is equal to t cubed minus 3t squared, where t is greater than or equal to 0. And they say the function S of t describes a particle in rectilinear motion where S is in feet and t is in seconds. All right, part A. Part A says, find the velocity and acceleration functions. Well, if that's a position function, the velocity function v of t is just the first derivative of this position. So 3t squared minus 6t. There's my velocity function. My acceleration function is the second derivative of position, or the derivative of this velocity, which is 6t minus 6. Well, part A is easy enough. How about part B? Find the position, velocity, speed, and acceleration at time t is equal to 1. Find the position at time t is equal to 1. So all you do is evaluate this position function at 1. So S of 1 is equal to 1 cubed minus 3 times 1 squared. Well, what does that give me? -2? Now, if I'm talking about position, and it says that the position's in feet, we have -2 feet. So what does that mean? That means what? At 1 second, the position's at -2 on the number line, basically. All right, what do they want me to find? Position velocity. The velocity at 1 second means take this velocity function, evaluate it at 1. So v of 1 is equal to 3 times 1 squared minus 6 times 1. What's that? 3 minus 6 or what? -3. But what's velocity going to have also? Units with it. And a unit here is feet per second. How about the speed? Speed is what? The absolute value of my velocity. So my velocity at 1, take the absolute value of it. What was my velocity at 1? That was -3. So the absolute value -3 is 3. And I still have the same unit, feet per second here. And what's next? Acceleration? Acceleration at 1 second is going to be A evaluated at 1. So that's 6 times 1 minus 6, or what? 0 feet per second squared. All right, that's just tedious. It's not really that hard of calculations there. All right, let's look at C. C says, at what times is a particle stopped? Well, let me ask you this. When the particle stopped, what is the velocity going to be equal to when the particle stopped? Velocity is going to be 0, right? So just take your velocity function here, set it equal to 0. So 3t squared minus 6t, set that equal to 0 and solve. Well, I can factor 3t out of here, and we have t minus 2 is equal to 0. Take each factor here, set it equal to 0. 3t is 0, t minus 2 is 0, so t is equal to 0, and t is equal to 2. So when is the particle stopped? At 0 seconds and at 2 seconds. Let's see, D. D is in dog. Erase all this, give myself some room. Alright, then they ask, when is the particle speeding up, when is it slowing down? So what do I look at? I look at, for speeding up and slowing down, when the signs of velocity and acceleration are same, speeding up. When the signs of velocity and acceleration are different, it's slowing down. So maybe take your velocity function, and we're going to draw a number line with it, okay? Then we're going to take our acceleration function, and we're going to draw a number line with it, and we're going to see where they're positive and where they're negative. All right, so what was my velocity function? My velocity function I had was what? V of t was 3t squared minus 6t. And my acceleration function, a of t, was what? 6t minus 6, right? To find out where these are positive and where they're negative, let's find out where they're 0 first. So where is this one 0? Well, didn't I just find that over here? Found out there's 0 what? 0 and 2? How about this one? Let's find out where that's equal to 0. Actually, we already found that one as well, basically. So t is equal to 1, right? So what I'm going to do is I'm going to take my velocity function. I'm going to plot 0 and 2, or my number line, I'm sorry. Plot 0 and 2 on them. Actually, let me space that out a little more. And my acceleration function, let me put 1 on it. Let me also put 0 on it as well. Why am I putting 0 on it? Because this function we're looking at is defined for t greater than or equal to 0. So I'm looking at 0 beyond that way. Now let's run some test values right here to see, is my velocity function positive or negative here? And run test values here to see if it's positive or negative there. Pick a test value here, say 1. Plug it into your velocity function. Now, but if you plug in a 1 right here, you get a negative, right? Excuse me. All right. What about a test value over here, like say 3? Run 3 through your velocity function. What do you get? 9 times 3 is 27 minus 18, so that gives me a positive here. How about my acceleration function? Is it positive or negative here? I don't know. Let's test. Pick a test value, a half. So what happens whenever I pick a half right here? That's 3 minus 6 are negative, so I get negatives here. Let's test this part. Is this part positive or negative? Let's pick 2. What do you get? Positives here, right? Okay? Now, what are we trying to determine? Where it's speeding up, where it's slowing down? Well, let me ask you this. What's going on between 0 and 1 second? My velocity and acceleration functions have what? The same sign, right? So if they have the same sign, it's what? Speeding up. Let me go ahead and write slowing down here. But where is it speeding up? Between 0 and 1 second. So whenever t is between 0 and 1 seconds. Now what happens between 1 and 2 seconds right here? Well, my velocity function is negative there, and my acceleration is positive. So if they have different signs, my function is slowing down in here. And where is this between? 1 and 2. So between t values of 1 and 2 seconds, I'm slowing down. How about for 2 beyond? They're both positive, right? So what is my particle doing? Speeding up. So where's it speeding up again? Whenever t is greater than 2 seconds. There's where it's speeding up and slowing down. All right, what about the next part? E. Find the total distance traveled by the particle from t is equal to 0 to t is equal to 5. Part E. Find the total distance traveled by the particle from t is equal to 0 to t is equal to 5. Well, let's see. Let me do just a very rough sketch of this graph, okay? Here's t, here's s. We're looking at graphing a position function here, okay? Now, what's going to happen with this graph? Well, at 0 seconds, where am I at? At 0 seconds, if I plug in 0, I get out 0, right? So at 0 seconds, I'm at 0 feet. Now what's going to happen is my graph's either going to go up or it's going to go down, right? And then let's say it goes up like this, okay? Where does it stop and then go back down? Or if it comes down like this, where does it stop going down and starts coming back up? Wouldn't that happen at relative max or min values? Yes. And where do I find my relative max or mins? At my critical points, right? How do I find critical points? Find where my derivative is equal to 0 and find where it's undefined. Where was my derivative equal to 0? Wasn't it my velocity function, my derivative of this? Where was my velocity function? S prime of t we said was v of t. Now where was velocity equal to 0? What did we say earlier? We said 0 and what? 0 and I cannot remember. 2 seconds, right? So when t was equal to 2 and when t was equal to 0. Well, let's see. At 2 seconds, 1, 2, here's 2. Where is my function at? I don't know, so let's evaluate this at 2. S of 2 is equal to 2 cubed minus 3 times 2 squared. Oh, what does that give me? 8 minus 12, or what does that give me? Negative 4? So at 2 seconds, I'm down here at negative 4. So I have 2, negative 4. So my graph might do something like this, okay? Then I go out to what? I want to know from 0 to 5 seconds. So that's 2, so here's 3, 4, 5. Where's my function at 5 seconds? Where's my position function at 5 seconds? Well, let's see. Let's evaluate S at 5. So that's 5 cubed minus 3 times 5 squared. So that's what? 125 minus, what's that? 25 times 3 is 75. Oh, well, that should be easy enough, right? Should be 50. So what, in input of 5, I have an output of 50. So at 5, I'm at 50. 5, comma, I'm at 50, and it's much higher than that, but I'm just out of board space, okay? So my graph's got to come back up somewhere. Let's see, let's put 5, comma, 50 right here, so it's a better view. All right, so let me find my total distance traveled from t is equal to 0 to t is equal to 5 here. Total distance. Okay, so how does this work again? Where you're decreasing right there, you're going to see how much ground you covered, okay? How much distance you covered. So how do we do this? We say S evaluated at 2 minus S evaluated at 0. Put that in absolute values, okay? So in other words, you're taking the right output, or the rightmost point's output is subtracting the left one. Not the rightmost, but the one that's further to the right out of the two. Plus the absolute value of this output minus that output. So S at 5 minus S at 2. Well, what is S of 2? What's the output that goes with 2? Negative 4 minus S of 0. What's the output that goes with an input of 0? Is 0. Plus the absolute value of S of 5. What's my output that goes with 5? 50. Minus S of 2 is what? Negative 4. Alright, so this gives me 4 plus 54, or what? 58 feet is my total distance traveled. Let me see, did I answer all the questions there? Oh, we sure did. Sure did. Alright, let's do another one of these. Let's do another one. So if we look at our notes, what else do we have here? We got a more complicated one, right? That's alright, we can handle it. We have S of t is equal to t squared plus 8 times e to the negative t over 3, where t is greater than or equal to 0, s is in feet, and t is in seconds. S in feet, t in seconds. All right. Part A. Part A says find the velocity and acceleration functions. All right, so I know my velocity function is the first derivative of a position function, right? I'm going to use a product rule here. Product rule says first times the derivative of the second. What's the derivative of the second? E to the negative t over 3 times the derivative of the exponent times negative 1/3. Plus the second times the derivative of the first. What's the derivative of the first? 2t. All right, let's clean this up. Let me see. I could go ahead and factor e to the negative t over 3 out of both of these, okay? So I'm going to take e to the negative t over 3 out of this part and out of that part. Actually, let me write it closer to this way so you can see a little better. E to the negative t over 3 I'm taking out. So if I'm taking out this, what am I left with? Negative 1/3 times this stuff. Negative 1/3 times t squared plus 8. Plus, what if I took this out? What am I left with? 2t. Alright, so that gives me e to the negative t over 3. Now let's distribute this negative 1/3. So we get negative 1/3 t squared minus 8/3 plus 2t. Or I could rearrange these two and say this is e to the negative t over 3 times negative 1/3 t squared plus 2t minus 8/3, and that is what? My velocity function, v of t. Now they still want me to find my acceleration function. So for my acceleration function, I'm going to take this stuff and rewrite it over here, okay? V of t is equal to e to the negative t over 3 times negative 1/3 t squared plus 2t minus 8/3. All right, now I have room to take that derivative. So let's take that derivative to find a of t. Product rule again. First times derivative of second. So first is e to the negative t over 3. Derivative of this stuff will be negative 2/3 t plus 2. Plus the second, which is negative 1/3 t squared plus 2t minus 8/3 times the derivative of the first times e to negative t over 3 times negative 1/3. All right, can I take an e to the negative t over 3 out of both of these again? Factor it out? Sure can. If I factor that out, what am I left with? I'm left with negative 2/3 t plus 2 plus this stuff times negative 1/3 plus negative 1/3 t squared plus 2t minus 8/3 times negative 1/3, and let me close off that parenthesis. It's kind of messy, huh? It's all right, though, it's doable. E to the negative t over 3, then I have negative 2/3 t plus 2. Now let's go ahead and distribute this negative 1/3 here, here, and here. So we get what? Plus 1/9 t squared minus 2/3 t plus 8 over 9? Yeah. Now I'm going to combine like terms and put this in descending order. So I have e to the negative t over 3 times 1/9 t squared. 1/9 t squared. What else do I have? Negative 2/3 t minus 2/3 t is negative 4/3 t. Bam, bam, get rid of those. What's 2 plus 8/9? Well, 2 is what? 18 ninths? 18 ninths plus 8/9 is what? 26 ninths? And what is this? My a of t, my acceleration function. Now, if you did not get that, pause your video. Rework, see where you went wrong, and so forth. Don't just watch me work on blindly. All right, so that's my velocity and acceleration functions. Then it asks, where's the particle speeding up? Where is it slowing down? Where is the particle speeding up? Where is it slowing down? All right, so let me take my velocity function, and I'm going to look at a number line with it, okay? And I'm going to compare it to a number line with my acceleration function. And I'm going to say, okay, where do they have the same signs and where do they have opposite signs? So what do I do here? I find where is my velocity function 0 and where's my acceleration 0. Then I'll plot those numbers, and then I'll go on both sides of those numbers to see where it's positive and where it's negative. So let's take my velocity function. What was my velocity function? I had to erase it. It was v of t is equal to e to the negative t over 3 times negative 1/3 t squared plus 2t minus 8/3, and we're going to set it equal to 0 and solve. So e to the negative t over 3, I'm just going to set each factor equal to 0. This and that. Negative 1/3 t squared plus 2t minus 8/3 is equal to 0 as well. All right, I could call this 1 over e to the t over 3 is equal to 0. And if I multiply both sides by the least common denominator, I get 1 is equal to 0, and that doesn't make any sense. Let's solve this equation. Well, let's get rid of refractions. Let's multiply both sides by negative 3. So we get t squared minus 6t plus 8 is equal to 0. Now, can I factor this? Let's see. T, 4, 2, minus is equal to 0 should do the trick, right? So t minus 4 is equal to 0, t minus 2 is equal to 0, so that means t is equal to 4 and t is equal to 2, right? So that's what I'm going to take my velocity number line and break it up with. Let me put 0 on it as well from here, okay? So my velocity function, I'm going to put 0. I'll put 0 on my acceleration one as well. But let me also plot 2 and 4. Here's 2. Here's 4. Now, how do I break up my acceleration number line? Well, I'll find the zeros in my acceleration function. Let's do that now. So what was my acceleration function? It was a of t is equal to e to the negative t over 3 times 1/9 t squared minus 4/3 t plus 26/9, right? Now, instead of showing a step where I set this equal to 0, I'm just going to set each one of these factors equal to 0. So e to the negative t over 3 is equal to 0. And this stuff, 1/9 t squared minus 4/3 t plus 26/9 is also equal to 0. This one we solved and we got 1 was equal to 0 earlier. Said it didn't get us anywhere. Let's solve this equation. What if I multiply both sides by 9 to clear my fractions? I get t squared minus 12t plus 26 is equal to 0. Oh no, I can't factor that, can I? So if I can't factor it, what do I use? What's that beautiful thing you love using? Quadratic formula. So t is equal to negative b plus or minus the square root of b squared minus 4 times a times c. What's a? 1. What's c? 26. All over 2 times a. Make sure you got that. Alright, so t is equal to 12 plus or minus the square root of let me just see what all that is because I don't have room to keep writing out every single step right here. I got like 40 under my radical. All over 2. Now I can break this up. I can say t is equal to 12 plus or minus. Isn't this 4 times 10? So that's 2 square roots of 10 over 2, right? Now if I divide all 3 of these numbers by 2, I get t is equal to 6 plus or minus the square